associated editor for the Wind Energy Science Journal, and is part of the European Academy of Wind Energy. Good morning.
Hello, can you hear me?
Joining?
Can you hear me?
Yes.
Okay, so welcome. Good morning, everybody. Thank you a lot for inviting me. So indeed, it was my plan to attend the conference this year, but unfortunately, this week in Italy is crazy because we have started all the lectures and we have a brand new Master Science degree course on sustainable energy. So you can imagine that it is very complicated, but it is a pleasure at least to share with you this presentation from a distance. So can you see my screen? I think so, because I saw it in Zoom, so should be fine. So the title of my presentation seems a little bit pretentious today, but indeed this is the title of a paper that together with some colleagues we published last year in Wind Energy Science. And let's say the scope of today's presentation is to showcase the kind of work we did. And please let me state from the very beginning that this paper does not want to represent a solution rather than a starting point for stimulating further discussion about small wind turbines. So as you may know, the International Energy Agency, together with the European Academy of Wind Energy, promoted a couple of years ago a program, let's say collaborative program to define or to update the grand challenges for wind energy. And so after a little bit of discussion, small wind turbines have deserved one of the 10 papers on, let's say, representing the grand challenges. And the one I am presenting today is exactly a part of this collection. As said, you can find it open access to at this DOE in Wind Energy Science. So let's say the paper which actually presents the collection of the grand challenges paper is the one cited here in the slide that present this famous graph that Paul Viers presented at TORC 2022. It is called the Viers pyramid, and the sense of this graph is showing what we are doing. So in wind energy, the final goal is to have access to a carbon-free energy. For the moment, we have, let's say, already built these colored blocks. So utility scale wind turbines are already quite well optimized in terms of aerodynamics, of structures. We are able to make wind energy cost effective, and we are already working at plant level. However, the sense is that if you want to make this pyramid really stable and so really push wind energy forward and making the backbone of a more sustainable energy systems, we also need to build these other bricks. So where small wind turbines can find room in this pyramid, I would say here. So we still have to improve small wind turbines as let's say as energy generation system. In the paper, it is written that small machines have not received, which is, that is true. Up to a few years ago, they have not received the same design refinement level than utility scale turbines. But if we invest in them, they could really contribute to the energy mix. And to do that, so to add this brick to the pyramid, our vision is that we need to work on the different levels. So we need to improve the turbines, the structural and construction parts that we will discuss this in a minute. But we also need to work on social sciences. We need to work on at the installation level. It was very interesting to see in the previous presentation an installation of small wind turbines in the mountains. So again, we need to work at different levels, and this is the sense of the paper I will be presenting. So a short, non-linear story of the paper. As you may know, the European Academy of Wind Energy has created a few years ago some technical committees to as collaborative groups to foster the research onto different topics. I had the pleasure to lead the small wind turbine committee for the first 2 years since the foundation. And one of the very first scopes of the small wind turbine committee was to deliver a white paper on as you can imagine, on small wind turbines. But what became apparent very soon is that the original plan was to have it on Europe, but that paper was a little bit reductive. So the topic needed a more comprehensive approach, and also we needed to gather competencies and experiences worldwide, because let's say Europe is not the only and probably not the biggest market for small wind turbines. So the group became much bigger. We had contributions from other colleagues in Europe as well as all over the world, and also coming from different backgrounds, which is also very important. So the paper had two main scopes. The first one was providing an overview on the status of small wind turbine technology. So if you take a look to the paper, you will see that sections 2 and 3 provide an overlook about the market diffusion, some updated economic data, very interesting, but and also a description of the main technical features of small wind turbines in comparison to utility scale ones. Due to time, of course, I would not presenting anything about this in today's presentation, but if you're curious, you can go and find them on the paper. The second part was, again, defining, for at least from our perspective, 5 grand challenges that we suggest as key to foster the development of small wind turbines in the near future. And please let me repeat that again. We are not saying this is the only solution. Many of you have experience into this field and probably may have visions which are a little bit different from that. But again, the scope of the paper was to restart and stimulate the discussion on the topic, and to try to be as systematic as possible. What we tried to do was first to define a series of unknowns and gaps for small wind turbines, and then try to rationalize all the inputs and all the experience of the authors into defining improvement areas and prospects to address these existing gaps. So, as said, first we try to highlight at least some of the unknowns and knowledge gaps for small wind turbines, and we turn it out into 6 main categories. The first one is that in general, as you perfectly know, small wind turbines are entitled of having higher levelized cost of electricity with respect to utility scale wind, mainly due to the lack of economy of scales and to higher balance of station costs. The second element, so the second, I would say, drawback is an uncertainty in the actual power curves. So not too many turbines have certified power curves. I was very happy to see before that some good producers are now providing very high quality products, but if you make an average worldwide, this is not always the case. And also we have uncertainty into the local wind conditions, and we will see why. And this in turn come into a poor estimation of the annual energy production. Another drawback is that over the last decades, we saw intermittent incentives, regulations, feed-in tariffs, or whatever between the countries, and they were not only different from a country to another, but also intermittent in time, which makes it very difficult for producers to stay in the market. The fourth element was the lack of openly available data. which are very useful to improve the models. We have to fine-tune the design tools and the estimations of the real production. The final two elements is, the first one is social acceptance and environmental issues. So small wind turbines likely, as you perfectly know, are installed quite close to the built environment, or let's say the populated environment, which let's say exacerbates a little bit the problem of visual impact, noise, and the perception of the populations. And finally, it is apparent that there are still concerns with the small wind turbines reliability and also with problems of certification. So overall, as said, these are not all the gaps for sure, but we tried at least to summarize them into that. So moving from this background, the paper suggests 5 grand challenges that you see listed here, but I would not read them all, and we will try to analyze them a little bit more in detail. So grand challenge number 1 is to improve the energy conversion of modern small wind turbines through better design, control, especially in the case of turbulent wind. So I came from the aerodynamic design. I'm an expert of airfoil aerodynamics in turbulent cases. So this is probably my number 1 grand challenge. So the background is that, as we have said, small wind turbines traditionally did not receive the same level of design refinement, as very often to keep the cost low. And also, they are typically installed in areas that have lower winds and more turbulent and gusty oncoming wind. And so maximizing the energy harvesting in these cases is not easy. And that's why many wind turbines have been shown to underperform in comparison to expectations. So what we can do to tackle this grand challenge? For sure, we need to get a better insight into the impact of turbulence and gustiness on turbine performance. We need better design and analysis tools that are able to account for this so complex blade flow interaction. We need to find solutions to exploit these winds better, which means taller towers or different designs of the rotors, like for example going to low specific power rotors to be able to harvest energy also at lower wind speeds, and multi-objective design, for example, to make very efficient turbines while keeping the cost low. So moving to grand challenge number 2 is improve the prediction and reliability of long-term turbine performance despite limited research measurements. As you know, defining the long-term performance of a turbine is mainly made by combining, let's say, 2 elements. First one is having a good estimation of the actual power curves. Second one is to correctly estimate the resource. And doing this is not always easy because we often lack reliable measured data. And so what we can do to tackle this grand challenge, having data, possibly open access, is very important, especially because we miss mesoscale modeled data for this low wind speed where the effect of obstacle is very relevant. And that's why we would also need methods that can better model the impact of obstacles into real installations. And finally, we would need to develop methods that prove that small wind turbine technology can really operate reliably over its design life. Grand challenge number 3 is probably the most difficult one and the most relevant one, is to improve the economic viability of small wind energy. This has been discussed also before, so we need to have competitive LCOE. And this is particularly tricky because of the cost of the materials, the installations cost, and also because it is so small wind turbines have not coalesced into a single archetype, which makes the creation of standardized and solutions and the creation of economy of scales not always easy. So the actions that are suggested, so we need to reduce the costs, and these can be done by multiple actions. So we can optimize the design, of course, exploring new material, new manufacturing techniques. Very important, try to access standardized solutions that potentially can be applied to multiple turbine models, such, for example, as power inverters. So to incentivize the production of economy of scales, and also reduce some items which are very important, like foundations, tower, and our other balance of station costs. Grand challenge number 4, facilitate the contribution of small wind turbines to energy demand and electrical system integration. So currently we have around 1.8 gigawatts of small wind power all around the world, coming from 1 million turbines. So a lot of very small insertion of power into the grids, and the highly discontinuous power production from small wind turbines can be hampered in some grids, which have restrictive limitations in terms of ramp rate. And so if we want to convince people and communities and politics that small wind turbines are really competitive with PV panels, we need not only to make them more efficient, but let's say to integrate them very well with the grid. So for sure, so the action that we need to put in place, small wind turbine technology must advance to meet the evolving grid code requirements. And if we invest money into that, we also need to ensure that the value they may add, that small wind turbines may add to grid reliability and resilience is properly monetized and highlighted. And also, as you perfectly know, there is an increasing importance of energy storage, so an effective coupling between turbines and storage for a variety of reasons, so load shifting, but also power quality, like power smooth. Moving to the fifth and last grand challenge, it was called foster engagement, social acceptance, and the deployment for global distributed wind market. So NIM business is still hampering a lot of potential installations, and so to overcome this issue, we need to enhance the social understanding of small wind turbines, provide real evidence that the modern turbines, as the example we have seen before, are really able to perform much better than their predecessors. We need to put a special attention to environmental impacts, so to ensure communities that the installation of small wind turbines nearby their houses or buildings or facilities is not a risk. And also we need to push and harmonize politics and regulatory aspects and promoting the harmonization of them among countries, because this would really allow the deployment of the technology in a more effective way. To do that, the paper suggests 10 key enablers. So I'm running out of time, so I'll go quickly through them. But if you're curious, of course, in the paper you will find many more details. So the 10 key enablers, first one is the more effective use of air elasticity into small wind turbines. So air elasticity is the base for the design of larger scale turbines. It has been used not that much in small wind, but if you want to improve the design of the new machines, for example, going towards lower specific power rotors or having lighter, more flexible blades, we need to introduce air elasticity. And to do that, we need to also train the personnel of the producers to use the codes and to, let's say, really understand elasticity. We need to improve in control strategies. So we are seeing a fast transition away from furling towards more advanced controller stall strategies. There are also some examples that are showing that individual pitch control, even though it is difficult to be included into small wing due to mainly space in the nacelle and cost, but could provide a real improvement into the production and also an alleviation of the loads, which is again could be potentially very useful to make blades that are lighter and also cheaper. We need to improve the aerodynamic design, especially with focus on low Reynolds airfoil aerodynamics in turbulent environments. This is relevant not only for performance, but also to ensure, for example, a better control when you design a stall control-based machines, and also to reduce noise and to account, for example, for air density variation. The example we saw before of a small wind turbine installed in a mountain is very, very nice, but if you install a turbine at over 1,000 meters, the density change quite a lot, and so we need to be able to account for that properly. Fourth enabler to have, we have discussed this already, open data, both from wind tunnel and field experiments to calibrate and tune our model. Fifth one, more accurate performance and risk assessment. Again, we have already discussed it. This can be done both with experimental measurements and with the use of higher fidelity methods like CFD. Sixth, variable validation and verification. This is very important, and it is discussed a lot in the paper, because what we could do probably in the future, and you know better than me that design is evolving into this direction. Smaller turbines and more established archetypes could benefit from less onerous requirements in terms of load assessments, validation, and certifications, and this could speed up the process and also promote standardization. And standardization is exactly what we probably need, because it's very important to promote the economy of scale, and this in turn reduce the cost and make the LCOE more competitive. And standardization, as we were discussing into point 6, is also needed for regulations and standards. Coming to an end, so the 8th enabler, we need detailed studies on cost and life cycle analysis, because they are very useful to identify method to reduce the installation cost. We need to make small wind turbines more compliant, as we discussed it before, with the grids, and more tightly coupled with storage systems. So small wind turbines should probably become variable speed, make full use of AC, DC, AC converters, and they need to be coupled with fast response storage systems to allow for power quality and grid stabilization capacity. Finally, we would probably need to push and promote shared programs of incentives, new paradigms, to support the diffusion of small wind turbines, and particularly we would really try to convince to keep this program alive and stable for a sufficient number of years, so that producers can really stay in the market. So this closed my presentation. So the final question is, are we ready? Again, please let me thank all the co-authors of the paper. It was a great working group, and I would say also a group of friends. So many credits to all of them. I am presenting on behalf of all the authors, and let's say I really hope that this paper can further stimulate the discussion and promote events like the one we are attending today, which are very, very important. Thank you.
Thank you very much, Alessandro. Very interesting and very nice to see also many well-known names in the study.
Yeah.
Is there any question from the audience?
Probably there would be too many, so I understand it's difficult to make a question. And as said, the paper is quite big. It's 35 pages, and it is conceived to stimulate the discussion. But I really hope we will have some neat and nice advancements in the future, and I'm seeing part of that already in place. So I'm following some of the companies. I saw many of them participating here, and the progress into new products is very interesting.
Yeah, and also you can put the link in the chat.
Absolutely, yes. I'll put the direct link to the paper in the chat.
Of the work in the chat, so people can access it and read it with some calm as well.
Absolutely.
But yeah, otherwise, thanks a lot, and I hope that you have the chance to join us in presence next year. Would be really nice to have a big in presence event so that we could have a lot of networking as well. But yeah, so far that's what we have. So thanks for joining also with very short notice.
I'll try my best to attend next year, I promise. Thank you for inviting me, and I really it's a pity that I cannot join you for the entire week, but I need to run lecturing in a few minutes, so sorry for that.
No worries. And it is on YouTube afterwards, so you will not miss anything.
Perfect. Thank you. Bye-bye.
Bye-bye. Thanks a lot.